again दोस्तों, welcome to fauzibaba classes. In the last class, we were studying the non-destructive testing. Under that, we have seen the various methods of non-destructive testing. And liquid pentest testing being one of the popular, we studied in that class. But this liquid pentest testing method has got some limitation, as it works on the principle of capillarity. If the crack is on the surface, then only this method is useful or it can be applied. But if the crack is below the below the surface level, or if there is the internal crack, or if there is any other internal defect, this liquid pentest testing has got its limitation. For that type of defect, you have to choose some other type of method, and we will see one of that. Today we will see the industrial radiography. Industrial radiography is very useful and important method which is used in the field of industry, repairing or manufacturing to find out the internal defect. This defect can be crack, can be dislocation, can be shape, can be determination of certain length, it can be certain inclusion of that foreign material. So it has got a very wide range. Approximate 25 to 26 type of defects can be detected with the help of radiography. So this is a very important and very interesting topic. All the science students who will be watching this video will be enjoying this topic. This radiography has got two major types: the radiography with the help of X-ray and the radiography with the help of other ionizing radiations, mainly with the help of gamma ray. We will be seeing this topic in the two classes, so that the video length is not very high and the person who is viewing can understand this topic very easily. Today in this topic we are going to see industrial radiography with the help of X-rays. As you know, this X-ray is used in the field of medical radiography also. The principle remains the same. Once you are seeing and you are understanding this industrial radiography X-ray principle, that will do in the field of medical radiography also. Only some parameters may vary. Let us see. We will see under these heads what is the definition of the radiography. It is a technique, method, or by which it is a technique or method of imaging to find out the internal defect of a material, and that defect can be read over a X-ray film. This has got, as I told, two major types of radiography, that is X-ray radiography and the gamma ray radiography. Now let us see what is the X-ray radiography and how the X-rays are produced. All the science students know very well that X-rays were invented by Sir Röntgen in year 1895. Earlier, this X-ray tube were called Collis tube also, but with the passage of time, certain modifications were carried out. Now in the present scenario, this is called X-ray tube only. I am going to make a schematic diagram of this X-ray tube. By that you will be understanding how the X-rays are produced. This is a vacuum tube. The vacuum pressure is of a very high range, 10 to the minus 4 PA. Here one cathode end is there and another anode end is there, As you know, cathode is negatively charged, anode is positively charged. At the cathode end, some heating elements, mainly of the tungsten, is fitted, and at the anode end there is a target which is also made of tungsten, as its melting point is very high, say in the range of, it is approximate 3422 degrees centigrade. When this cathode and anode are connected through electrical power supply, but the potential difference between this cathode and anode is of very high. It is not in the range of some 250, 100, 300, 400 volt. It is in the range of kVs, 100 kilovolt, 300 kilovolt. Like this potential difference is maintained on the cathode and anode, between cathode and anode. You might have read thermionic emissions. When this cathode filament is heated with the help of electrical supply, what happens? The electrons are released from this filament and they make an electron cloud here. Same thing happens in the photoelectric effect also. When the sunlight is impinging upon a metal, after receiving the energy, the outer cell electrons release from that cell and the photoelectric effect takes place. So, due to this heat, electrons are released from the material and they remain here. They form a electron cloud, means a crowd of electrons available at this end. But you have made a provision that a very high potential difference is being maintained between this cathode and anode. So what will happen? These negatively charged electrons will be attracted, accelerated, running towards this target, and they will be striking here. Due to this high potential difference, they will be suddenly accelerated, and at this target they will be suddenly stopped. What will happen? Due to the sudden stoppage, if a man is coming with high speed and suddenly you have stopped him, what will happen? He will hit you. That energy will be transferred to you. What will happen? This energy of these electrons will be transferred to the material of this target and X-rays will be produced. This is the general principle of production of the X-ray. Once again, before going forward or before going in detail, I'll revise this. This is a X-ray tube which is made of high pressure of vacuum. Here cathode and anode ends are there. At the cathode, heating element is there. At anode, there is a target which is embedded inside a tube. Since this target will be subjecting to a very high temperature, so there can be a cooling arrangement also. That may be water cooling or some other arrangement, so that heat which is produced due to this strike of this high energy electrons can be dissipated at the end. This target can be made rotating also, so that all the surface are subjected to the strike equally. These arrangements can be made. But here we are seeing the simple principle. When these high energy electrons are striking to the target, what happens? They transfer their energy to the lower cell electrons of that atom. As you know, in general nature, when the outer orbit electrons receive certain energy, that releases that surface. But these electrons are having a very high energy. So once they strike to the atom, they have sufficient energy to energize the lower cell electrons also. Once the lower cell electrons receive this extra energy, that leaves its cell, but for making the balance, the upper orbit electron has to come back to a lower cell. In this phenomena, all the science students know very well, when any electron comes from the upper orbit to the lower orbit, it releases the energy. Here also the same thing happens. The upper electron comes to take the place of the lower orbit electron. In this phenomena, some energy is released and X-rays are produced. These produced X-rays are shown here. Now, when these electrons strike to the atom, some other phenomena also takes place. Some type of scattering takes place, Crompton scattering and all. That I will discuss in the detailed NDT level 2 class, when I will teach you attenuation factor of the material. This attenuation factor is going to decide how much and in the which ratio that particular electron or atom can be ionized with the help of X-rays. I will discuss the range and voltage also and timing also, how these ionizing factor affects the attenuation of this material. That I will teach in the NDT level 2 class. Here we are discussing NDT level 1 class, so that a simple layman or an operator acquaints himself with all the activities of the X-ray radiography. These produced X-rays are here to carry out radiography, which we will see here. Now, one more thing you should remember, the 99% energy of these electrons are utilized to rise the temperature of this target. That's why I told you it is made of very high melting point and there is a provision for dissipating the heat also. But only approximate 1% energy is converted in the form of X-rays. Now the next topic, what you will do after producing the X-ray? You have to get some information. How you will get it? Suppose this is a metal piece. It has got some cracks. It has got some holes. And it has got some other defects. Now, what happened? You have placed one X-ray film here. X-ray film. What will happen? Once these X-rays are falling over this metal piece, now let it come up to here. This is the X-ray film. This metal piece, what will happen? Where there is a hole, where there is a crack, more amount of X-ray will be passed from that metal, and where there is a solid piece, with respect to these areas, less amount of X-rays will be passed here, because some amount of X-rays will be absorbed by this metal or by this object. but not all. It can absorb maximum also if your energy of X-ray is less. But I will discuss how these things are controlled. First, let us see what happens when the X-ray are falling over an object. When these X-ray are falling, exactly what happening? Places where less material is there due to some defect, due to holes, due to cracks, or due to availability of some foreign material whose density is not exactly equal to the base material, what will happen? The more amount of X-ray will pass from that place, and the film just below this will be darken more with respect to these areas where no cracks or defects were available. Very simple. Let me explain again. Let us see a 3D shape. Now this is the object. In between there was a hole. This is the X-ray film. X-rays were falling. What will happen? Since there was a hole, with respect to these places, more amount of X-ray will come. So on the X-ray film, these information will be in the darker shape, and these other areas will be less darker, because due to this solid area, more amount of X-rays will absorbed by the material with respect to this hole. So on the X-ray film, these areas were darker where the cracks or deformities are there. This is the basic principle by which the information of the defect is transferred to the X-ray film. Now, as you have seen, these X-rays are absorbed by some amount of X-rays are absorbed by the material. So, if the density of the material, thickness of the material, and some other factors of the material are such where you need high amount of energy, because you need you need to penetrate these material. Until unless these X-rays are not able to penetrate this object, how they will carry the information in the form of varying density over X-ray film, varying darkness on the X-ray film. So you may need to control the energy of these X-rays. Once you are doing the X-ray of a 2 mm sheet, in the another range you are doing the X-ray of 5 mm sheet, in the another exercise you are doing the X-ray of 10 mm sheet. Equal amount of X-ray energy will not work out. Suppose you have selected a 300 kilovolt potential difference between the cathode and anode, and if you are producing the X-ray and putting this 2 mm sheet, what will happen? This 2 mm sheet is, suppose I am taking the stainless steel sheet. This 2 mm sheet is very thin, so that high energy X-ray will penetrate approximate all the portion of the material, and even if it will cross the cracks, it will cross that other portion also. But since energy is very high, the whole film will be darkened in such a proportion that you may not be able to differentiate while viewing the X-ray film where is the crack and where is the normal plane. So these energies has got a very significant role in the X-ray radiography. There are two things. Once you want to control the production of these electrons, you give the milliamperage to this cathode. You can change this milliamperage, and once you want to change the energy of these electron, you have to control this potential difference. For that you have a generator. This is a control panel. These control these activities of this X-ray tube. Now let us see some other factor. Suppose this is your object and you have kept the X-ray film after some gap. Exact image will not be transferred here because as you see in the nature of this X-ray, this follows like the torch light. If you put one object just near to the torch, its image will be very larger. But you put this object here and this is your curtain, the approximate exact side image will be formed. Like this in the X-ray also. So while placing the object and placing the X-ray film in this X-ray radiography, it is to be observed that there is no gap between this object and X-ray film other than if some odd or complex shape or nature of the object is there, that is unavoidable. Now, angle also. Suppose if your object is here and your object is too large, now you have your defect is here, you are pointing these X-rays to the middle half side, you have placed this X-ray film up to here, it may not receive the sufficient energy, this portion, so the proper information is being transferred here. So placing the object, placing the job is also a very important criteria in this X-ray radiography. Suppose you have a metal plate here. You want to do the X-ray of this metal plate. I'll show one example. Suppose this is your metal plate. If I place this plate like this, what will happen? Suppose this thickness is 10 mm or 15 mm. This 300 kV are in the range of that voltage. That energy is sufficient to penetrate this plate. But if I place this plate like this, will that energy will be able to penetrate this much thickness? No. So these are things to be kept in mind while doing the radiography. You have placed the item, you have got one image. That does not mean that image is have given you correct information. So placing the job has got a very significant role. In the correct radiography, these milliamperes, these potential difference, that is kV, the distance between the X-ray source and the object, type of film and the timing. Now coming to the timing. If you have placed a stainless steel of 15 mm thickness, this energy, whatever you have set in your X-ray tube, may be requiring say 5 minutes to penetrate. But if you place an item of 3 mm thickness, this may not require 5 mm and definitely it will require the less timing. This may require 2 minutes. So this timing is very important. If you allow these X-ray to fall upon this 3 mm thickness object for 5 minutes or 10 minutes or 15 minutes, what will happen? The so sufficient amount of X-ray will be transferred to the X-ray film, energy will be transferred to the X-ray film, that it will be completely darkened. So you will miss all the information. The area which is having the crack, that will also be darkened, and the area which is not having the crack, that will also be darkened, because these high energy X-rays will be able to pass that area also. So setting up the timing has got a very important role in that. Now, contrary to that, you have a 5 mm thickness object, you have just allowed it for 30 seconds. What will happen? These X-rays with this energy may not be able to penetrate completely as its thickness is very high. The material density, strength and some other factors are very high. So they may not bring the proper information in the form of darkening this X-ray film in the same proportion. So the setting of this timing for the complete penetration of this material is very important. These are things to be maintained as per the manual given by the particular X-ray tube or that material radiography manual. These are to be followed. I think this X-ray tube, production of the X-ray and this transferring of information to the X-ray film, I think you have understood. Now coming to the next topic. We have seen this procedure. Now coming to the X-ray films. See, nowadays film radiography is reduced to a very less quantity. Very few X-ray plants are there where the film radiography is going on. Nowadays, this has been converted to the computer radiography, tomography or some other things. But since this is this is a basic radiography method of the non-destructive testing, so I will give you just a glimpse of that one, so you could understand how this film radiography is being done. Somebody may be using this film radiography, so you should know the basic things. These X-ray films are soft gelatin material which are embedded inside two super coats of polyester and some other hardening materials are also there. Basically 6 layers are there in this X-ray film. Silver halides, say bromide or iodides are pasted in the X-ray film. After taking the X-ray shot, you need to wash or process this X-ray film, as this X-ray film cannot be exposed to the sunlight because it will darken all over area and you will get no information. So you need to process these things in a dark room where the darkness can be maintained. Here 2 chemicals are basically used, that is developer and fixer, and at last you wash it, that is water. Developer is nothing but it is a compound of hydroquinone. That X-ray film is first, suppose this is a X-ray washing plant, this is a developer tank, this is a fixer tank and this is a water tank. You will put the X-ray film in the developer tank. Next you will take out and you will put in the fixer tank, then you put in the water tank, then after cleaning you take it out and get it dry. Fixer is nothing but it is called hypo sodium thiosulfate Na2H2O3 some XH2O 5H2O or so. It is a material called hypo. X-ray films are passed from developer to the fixer, and then when you clean and get it dried, the X-ray film will be having information over that, and that you can view on a viewer. For viewing also, you might have seen a backside there is X-ray viewer are there. Some other types of viewer are also coming. You put the X-ray film here, white light is coming from the background and X-ray film is just placed over this. All the places which are having blackness and all the places which are having some sort of defect can be viewed easily. Here also, this blackness, this amount of darkness, that is density of the X-ray film, has got a role. Suppose you have processed the X-ray film, you brought to a viewing bay and its darkness is much or very low. Where I was working, it was in the range of 2 to 4, but this may vary to some other plant, to some other agency, to some other manufacturing guidelines. This darkness should be in the certain range, because if the X-ray film is not much darker, it may not carry the defects over the X-ray film, because the sufficient penetration of the material would have not been taken place. And controversy to that, if the heavy darkness has been given to this X-ray film, that means much more amount of energy has been given to the X-ray film, either by the X-ray radiation, either by some sunlight, either by some sort of other radiation. So again, if there is a heavy darkness, you will not be able to differentiate between the cracks and all the non-cracks area. So here also your density of the X-ray film has got a very important role. Now coming to the precaution. As you know, the X-rays are called ionizing radiations. If they can penetrate to the 10 to 15, 20 mm of steel, definitely they can penetrate to the human body also. So sufficient precaution are to be taken by the X-ray operator while doing this X-ray job. Generally, this X-ray tube are made safe so that X-ray are not coming out, and this X-ray phenomena is carried out inside a lead cabin or inside a high thickness concrete cabin, but the operator has to go inside the cabin, let it be after switching off the X-ray. These high energy electrons, few electrons may have received such an amount of energy, they can penetrate to that thickness of this lead also. Few, not all. So you have to take the precaution. You have switched off the X-ray with the generator, you have switched off the power supply, the production of X-ray has been stopped, but high energy electrons might be present in the cabin, and that may damage your human body or cells. So precautions to be adhered, especially given by the X-ray plant manual and by any local authorities. Generally, there is a radiation survey meter available with all the X-ray plants and the operators. Before entering the cabin, even after switching off the X-ray, you should monitor whether any leftover ionizing radiation is there or not. If it is there, it will give you signal, let it be audio or video or in some beep. If it is showing some radiation and that is beyond permissible limit, do not enter, do not go. Allow some time. All the operators are given X-ray dosimeter. They have to place on their body or chest when they are working this radiation job. So whatever amount of radiation, if by mistake they are receiving or by virtue of their job they are receiving, that is to be monitored in this dosimeter. And on the monthly basis, quarterly basis or yearly basis, the cumulative dose can be monitored against each operator. These X-ray plants are to be registered under guideline of the AERB. If you visit the website of the AERB, there is a column where you have to register for X-ray plant. The AERB is Atomic Energy Regulatory Board in our country. This works as per the guidelines of BARC. You might have listened. Baba Atomic Research Center, which deals with all these nuclear radiations. So these two agencies give sufficient guideline to the X-ray operators, especially in the field of industrial radiography and also in the field of medical radiography also. Those guidelines and the maximum dose received by that operator is to be strictly monitored. This is the duty and responsibility of the employer also, that his employee is not getting the dose beyond the permissible limit given by these agencies. This unit of this dosimeter are in the form of R, that is called rad. This is exposure dose, and small r, this is received dose. Sometimes it is called sievert also, SV. So as per the local guidelines or that particular agency, whatever unit they are following and whatever amount they are following, you should follow strictly. Precautions are very, very important in the X-ray radiography. In the next class, I will tell you how this gamma ray radiography takes place, all the points of the gamma ray radiography, starting from artificial radioactivity to precautions of the gamma ray radiography, plus some major accidents of in the field of radiography which has been in the past. I will teach you. Jai Hind.